Next panel. Interesting panel, in my opinion, but, I think the program as such is interesting. Onwards to Mars. Yes, that's what I want to do. Although, truth be told, I was just eating a banana and thinking, if I'm on Mars, would I have a banana? I would miss that, and I would miss other things too. Never mind, I would go, though. I would simply leave those things behind. Now, the pleasure, of course, is mine to introduce Dr. Cooke, who has been working, I think, his whole career relentlessly to get us there. And he is, after 38 years at NASA, he's still doing it now in the private sphere. And so, Doc, I leave you to introduce your panel and get us to Mars.
Right. Thank you, Artemis. Thank you very much for this opportunity. Our panel is Onward to Mars, and the date's 2024 to 2033 approximately. First thing I'd like to do is introduce our panel. Our panel is made up of people who have been colleagues and friends of mine for quite a few years, including Frank Moring, who was not able to be here today. But I think we'll get some really good perspectives. Start with Dan Dumbacher. Dan is the Deputy Associate Administrator for Exploration Development Division for the Human Exploration and Operations Mission Directorate at headquarters. And in that capacity, he provides leadership and management for the organization with special focus as the Program Director for Exploration Systems Development. And that includes Space Launch System, Orion, and the ground systems. Prior to this assignment, Dan has served as the director. This is all chopped off, so. He has. He was head of engineering at Marshall, and supported all programs that Marshall supports in human spaceflight. He's also been has had a really a great and career and has worked on many programs. He was Deputy Director of the Ares Projects Office. He was Deputy Director of Product Assurance and Safety and Mission Assurance for the Space Shuttle return to flight efforts. Manager of the X-37 Flight Demonstrator, Deputy Manager of the Space Launch System Program. He's Program Manager of Second Generation Reusable Launch Vehicle Program, a Deputy Manager of the X-33 Flight Vehicle Program, Assistant Manager for the Space Shuttle Main Engine. Dan joined NASA in 1979. He earned his bachelor's degree in mechanical engineering from Purdue, right? That was chopped off here too. And a master's in business administration from the University of Alabama in 1984. He's married to Lee Dumbacher, and they have 3 grown children. Next is Mike Raftery, who is at the Boeing company. Mike is the director of the ISS Utilization and Exploration for Boeing's Space Exploration Division in Houston, Texas. In this role, he leads planning and execution for full utilization of the International Space Station as strategy development for future human exploration beyond low Earth orbit. Mike has been with Boeing since 1980 and has served in various leadership roles on key Boeing programs such as International Space Station, Crew Exploration Vehicle, Sea Launch, and the 767. He's an avid history buff and the proud father of 2 Texas Aggie grads, which I'm appreciative of, since that's where I went to school as well. But I think you'll enjoy listening to what they have to say, and so we'll get started. I have a few things that I wanted to say to kind of couch the conversation, starting with the Yogi Berra quote. If you don't know where you're going, you might wind up someplace else. Well, I think we know where we're going. We're going to Mars. And the question is, how do we get there? And what steps do we take? And what all is involved in that? In the 2024 to 2033 time frame is a time where we really need a plan on the intermediate steps and what steps do we need to click off on going to Mars. And I believe as we develop those, it should be a collaborative effort with the community and stakeholders so that we have those debates in an organized way. As you know, there are debates on what we should do next. But I think an organized approach to having the debate is probably preferable to the unorganized debate. And you always get some, of course, you get some debate around the edges anyway. So we'll discuss the various aspects of this time frame and preparing to go to Mars in this session. One thing I wanted to talk about a little bit is what are the considerations for developing a plan such as this? One, of course, is destinations. There's the moon, there's cislunar space, there are asteroids, there are the moons of Mars. Those are the ones that we think about as possibilities, and we should think about them in terms of what we can learn and what they offer in terms of preparing for Mars. It needs to be a sustainable program. We've talked about that. Various people have talked about it here in this conference. And how do we get at that? Part of sustainability is having that debate and getting through to a consensus. Part of sustainability is in the interest that the programs generate. And while we in the government and industry talk about how we're going to do these missions and what we're going to do, we need to be mindful of what these missions give back to the society. That is really why we're doing it. It's not, I mean, all of it, being an engineer, I'm real interested in the missions. I'm real interested in the spacecraft. But part of the consideration and one of the things we need to think about is what we give back to our stakeholders and the public. I meant to actually click this a minute ago. These are various destinations I talked about. I won't go through what's on the chart. Part of sustainability we have shown through International Space Station is international participation. That's been important. Science and the knowledge that we bring back from going to these places is important for sustainability and the understanding of our solar system. Providing commercial opportunities along the way is a component of sustainability. Living off planet is something that various communities are interested in. Affordability is the one that we always get to, and that means, in my mind, affordability means that that you're providing something that has enough value that people are willing to pay for it. And I think so. All these factors in sustainability, all the various components, I think are important as a part of that discussion. And of course, the budget sustainability is important. And we talk about change of administration and trying to have some stability through those. But right now, you can go ahead and figure that in the change of administration coming up, all the various people who are arguing different approaches, whether it's going to the moon, whether it's going to Mars, the asteroid mission versus those who want to do other things. Those are probably the talking points from various individuals, and depends on who gets elected, which one prevails. So I think you can almost predict what kind of discussion there's going to be and what basis it's going to be on. It's important to have a program that is flexible and is adaptable and can make those steps. Let's see. So part of sustainability is having the most efficient way of getting to where we want to go. I believe we want to be adaptable. We want to have a program that doesn't waste any money on offshoots or rabbit trails. And we need to have the most compelling missions for any number of reasons from a scientific standpoint or from the interest they generate. Let me just put up a chart. So this is an old chart from 2007 that we put together. It was lunar oriented, but the point I want to make is we put together a lot of objectives with various parts of the community in trying to understand why we go to the moon. And so once we did that, we lumped them into basic themes, which is what these represent. So the themes were stepping stone, prepare for Mars, scientific knowledge, sustained permanent presence, economic expansion, global partnership, inspiration. These, I think, are probably not unlike our long-term themes and objectives long-term. But what I want to warn against is that basically most of what we talk about in these conferences is the very first one, the stepping stone. And we can't forget the others, because those are the things that other constituents, other stakeholders are also interested in. And we have to prepare for Mars. That's the thing that we do as engineers in our industry. But the others are very important and can't be neglected, in my view. So I think that's an important point. So we can't forget these other themes. And we also want to know what we do when we get to Mars. I mean, yeah, we're going to get to Mars, but we need to think through follow-on steps. Are we going to go to different places? Are we going to set up a base camp in one particular place? Different objectives will send you to different solutions. And I happen to be a Civil War, I can't say buff, it's worse than that. I live in Gettysburg, and here's an example of what you don't want to do. So most of you are aware of the basic Pickett's charge at Gettysburg, where Confederates walked across the field over a mile by the thousands and were badly broken up by being fired on by the Union troops on Cemetery Hill. A few of them made it across the wall. Actually, not quite a small number. But one of the things that historians have talked about some since is that once they got over the wall, they didn't know what to do, because all they were supposed to do was break through the line. So they all retreated. Well, we don't want to get in that situation when we go to Mars. We want to get there, but then we need to know what the next steps are. And so we should think about those as we do this. So there, Kent showed this a little bit earlier, a different version of it. Basically, there are different ways of going at it. We need to find the right path. I'm not going to go through that. Also, I would submit, and I showed this at the Goddard Symposium, I would submit that we need to think about how we get at where we end up. You can go at it by various agendas driving space policy that then drive budget, that then drive a mission, and then you worry about the strategy of what you're going to do with it. In my view, we really need to look at it from a standpoint, from a vision with imagination, leading to goals and strategy, leading to space policy, then budget, then missions. And so what we don't want to do is have a varied path to Mars from where we are today. We want to understand a path and develop one that makes a lot of sense. So with that, I'll be quiet, and I believe that's it. And I'll turn it over to Dan. Thank you.
Thank you, Doug, and good morning, everyone. What I'd like to do is, listening to the conversations yesterday and today, is we're all headed to the same place, as Doug says. We all know where we're going. The message I want everybody to walk away from is we're actually going there, and we're doing it. And so the first thing I'm going to, whoopsie, these are the wrong charts.
Might be good, though.
Whoa. Okay. Aerospace safety. Okay, I didn't realize, I didn't look at the title, the Aerospace Safety Advisory Panel Charts. That was yesterday.
Hey, Dan, I could go, and you could, if you have it with you.
I don't have it with
You don't
me,
have
but
it
I
with
can
you.
go try to fix it here.
You want to try?
Yeah, why don't you go ahead, Mike? I don't know how we got that set of charts. Let me go back and check.
This is what's called flexible path,
Yeah.
okay?
Very good.
So mine are ready, it looks like.
Who's running the chart?
What I want to try to do
running
for
the
a little bit of time this morning, and we want to save a pretty good amount of time at the end for discussion too. So like we just did with the previous panel, we got a good discussion going there. We want to do the same thing here. So I only have a few charts. But this is a few charts from a much bigger package. We really don't have time to go through it all here this morning. But if anyone's interested in it, get a hold of me afterwards and we'll talk, and I can provide that to you. This is a study that Boeing did with RSC Energia, who is one of the companies over in Russia. We did this together over the last few years, just looking at how might we do this mission. So I don't want to imply this is the end-all way to do the mission. This is just a way to do the mission. There's a lot of debate out there about how this mission should be done. We titled this 6 Not So Easy Pieces, because each of these pieces are not so easy. But we are on our way. And part of the idea behind this was if you can minimize the number of developments that have to be done, developments are what usually drive costs. And if you can minimize the number of pieces that it takes to do the Mars mission, then you're going to bring the cost down. So that was the basic idea behind it. And these are the 6 pieces, okay? And the good news on this chart is that we're already working on 2 of the 6 pieces. So the 2 pieces on the left are the ones that we're already working on, and the ones on the right are the ones that still are in front of us. And so what I want to do is just spend a few minutes talking about those pieces and how they might be used to do a mission. And the 2 on the left, you can see, are associated with the Earth's gravity well. So the first phase of this is to deal with the Earth's gravity well. We have to be able to get out of the gravity well and back in.
They've got the ASAP charts, not the,
Dan?
hold on a second.
Oh, we need to just turn this off, or?
No.
Oh. Okay, Dan, yeah, Dan. That's okay, that's all right. Okay, so the second phase of this has to do with in between the 2 gravity wells. So you have the Earth's gravity well and Mars gravity well, and in the middle, you have to get back and forth between them. So that's the in-space transportation part. And we talked this morning already about one of the parts of that is habitation. We need to have some kind of habitation capability that the crew can live in while we're doing this transition. Now, what I'm showing here in our study is an inflatable habitat, but as we saw earlier, Josh showed some charts that showed a Russian habitat that would make sense, and there's some commercial options out there. So I don't want you to think that these pieces are exactly what they would have to look like. These are probably locked down. These are all still in play as far as what they might look like, okay? And then in addition to that, we need some kind of propulsive, in-space propulsive capability, and so we need a tug. Now, we talked in the previous panel about nuclear thermal as an option. There's also nuclear electric. I'm going to show you solar electric. These are the different options that are in play and are being debated. And I'll try to explain why we picked this one. Then the next phase, the last phase, will be the Earth's gravity well. We have to be able to land so we have to transition through the Mars atmosphere to land. And then, assuming the crew's coming back, right, which we are assuming, then you have to be able to ascend from the surface of Mars back into Mars orbit, and that's where you need some kind of an ascent vehicle. So if you think about it, a lot of these capabilities are very similar to these, they're just inverted, right? So we have a little rocket and a big lander, whereas over here we have a big rocket and a little lander. Okay, so that's really top level. These are the pieces that we need to be able to go to Mars and bring a crew home. Now, there are lots of other littler pieces that are needed, of course. As you all know, we need surface power, we need various other things, we need EVA suit capability and things like that. Now, the next chart that I have here is a notional time frame. I kind of come out of a program management background, so I'm always interested in when are these things going to happen and how does it all lay out in a schedule. So that was part of our study as we looked at that. And what I just want to do with this chart is talk through how this mission would work with these 6 pieces, okay? And what you can see here, first couple things jump out at you. Well, it's some number of SLS launches. I'm showing 5, okay? But it could be 6, it could be 4, it depends on what you're doing. This is a surface landing mission, so we're landing the crew on the surface and bringing them back. So it takes more to do that than it does just to go to the moons. Josh talked earlier about going to Deimos or Phobos. To do that, you would need the first 4 pieces. So you could do that first on the way, and then bring on the last 2 pieces and actually land a crew. And in this scenario here, the first thing we would do is we would land a habitat. So what we're doing here is we're pre-deploying capabilities that are needed on the surface that the crew would then use later when they've landed. So you're putting those capabilities in place ahead of time. And that does a couple of things for you. It allows you to test out a lot of these landing systems on basically what amounts to a robotic system first before you commit crew to that same approach. And that's always a good thing to do. We always want to practice what we're going to do first with robots and then do it with the crew. The second phase of this is when the crew goes. So another couple of things that jump out on this, and these are all specific to this study. We were using solar electric propulsion, so what we did is we used those to move the assets out to an assembly point. Now the assembly point that we used was EML2. And virtually any of these places out near the moon would work. We chose EML2, and that's what we used in our study. And then the systems were assembled there, and they went on from there. Now, there's a couple of things you can see here, too. You can see the transition from the lunar vicinity to Mars for the cargo habitat takes a pretty long time. It takes about 500 days. This is a pure SEP approach, so there's no chemical used. And what I wanted to bring out, because this came up earlier this morning in the previous panel, how can SEP be useful for crew? Well, it probably can if you use it together with chemical propulsion. So what we're doing in this scenario is we're using pure SEP here in the first phase, but then later when we go with crew, we take the SEP and we add a little bit of chemical propulsion, a small kick stage, and then together what we can see is very competitive trip times for the crew that are maybe not quite as good as nuclear thermal, but pretty darn close. Okay, so it's in the same ballpark. And what I really wanted to just bring this out is because this kind of study and debate needs to occur more thoroughly before we write off SEP for crew. We shouldn't do that yet because we really don't know. We need to do more study on this. And it looks like you can get pretty good trip times for the crew with SEP if you also add chemical, okay? So from a crew's perspective, though, they're the last ones to launch. And because you want to try to minimize the amount of time that they're on the total journey, so they're the last ones to launch. Basically, everything is all ready for them, and then they go straight from there. They spend a pretty long time on the surface because this is a conjunction class type mission where you basically are going for a long stay mission, and we want the crew to be on the surface as much as possible because it minimizes their radiation exposure. So you can see they're on the surface for 450 days, and then you can see the trip back home. So you can see a few things on this. One, it's a pretty long time frame. A mission like this takes a fair amount of time, so it takes a long-term commitment. And obviously, something like this is going to take a lot of preparation. So are there a lot of things that have to occur back here in the 20s in order for this to happen in the 30s? Okay, so hopefully Dan is ready.
I'll just point out a couple of things that are on a couple of things you touched on. We, a number of years ago, looked at solar electric and actually taking all of the big items, including the transit habitat for Mars, including the Mars hab, surface hab, including the ascent-descent vehicle for Mars, sending all of that out, cycling out to a very high Earth orbit with solar electric. And then you only need a tiny kick stage. You send the crew up impulsively so they get there in a smaller vehicle. Mm-hmm. And so, but all your big masses go out very efficiently with electric propulsion. Yeah. And then we just had a little kick stage to get them onto Mars.
And that's what Joe was talking about earlier, about a lot of the mass that we need really is.
Yeah, and one other point, I guess, just on a question that came up about artificial gravity on the way to Mars. There is actually a NASA report on that we did about 10 10 or 15 years, 12, 15 years ago that looked at that using nuclear electric propulsion and actually put together a feasible approach to doing that. There are other issues like rotational effects on crew and whether or not the biomedical folks like that, but there is a report on that for those who are interested.
One last comment I wanted to make about this. This is just a view of what this might look like. So this is looking at the lander piece, so pieces 5 and 6. This is the This is the lander here, and then this is the ascent vehicle that's sort of inside it. You want to have a sustainable program where you're going to be able to go again and again. So reuse of these pieces is very important. These pieces that are associated with the surface are probably going to be difficult to reuse, but the in-space stuff could be reused. So these tugs, they could basically cycle back and forth and be refueled and reused over and over again multiple times. So this kind of a concept, I think, is very important for sustainability. So I think that was all I really wanted to hit Doug, and hopefully...
Okay, why don't we start on questions then? And unless Dan's ready, we can get to him when he's back. Come back. All right, so we'll take some questions now while we're waiting and get started on that. There was, while we get somebody coming up, there was another question on Vasimir earlier. I actually at one point funded Vasimir, and so there. One unfortunate thing about Vasimir, which is basically a plasma engine that Franklin Chang Diaz has worked on over the years. One of the unfortunate things is that it always gets lumped with giant nuclear power sources. It actually has the same characteristics and performance, very similar to electric ion propulsion or Hall effect thrusters, and it can operate at lower power levels and have very similar characteristics to what electric propulsion would be able to do. So it's something that's always been tagged with that, because that's what he always advocates, that high power approach with a short duration mission, and but it can be operated at lower powers.
So I'm Steve Howe from the Center for Space Nuclear Research at the Idaho National Lab. I assume you're using Xenon for your SEP propellant?
Actually, in our study, we use krypton.
You do. And so if you do this multiple mission tug, what's the impact on the world supply of krypton? Is it that plentiful? Is it becoming expensive? I mean, you're going to be using quite a bit of it for these missions.
Yeah. So I'm not an expert on this in particular. I might lean on one of my Aerojet buddies for that.
I just remember the GEMO mission was going to use kind of the world supply of Xenon for the one mission. So I assume if you're going to do multiple Mars, that's kind of in this same.
I think that there's a lot of misconception about this. First of all, Xenon is produced as a byproduct of creating liquid nitrogen. So essentially, the plants that do liquid nitrogen, of course, is used industrially all over the world, right? And there's a lot of xenon in the atmosphere, and as they create this, they pull the xenon out and they store it off. If we went to those plants and said we would like to buy more xenon, they would be happy to sell it to us. And in fact, there's 10 times as much krypton in the atmosphere as there is xenon, so it's cheaper, and that's why we were using krypton.
So if I could just make another short comment. It seems to me that with chemical propulsion, we've kind of reached the fuzzy boundary where it's not quite enough to do the Mars mission. And it seems to me you're doing the same problem. You're locking us in with SEP on a similar technology that can, yes, it can do Mars, that's great, but really can it go past Mars? Can it do the asteroid belt? Can it go on past it? So you're building the next step technology with SEP that just locks into a niche performance. Of course, I'm a big NTR fan, and I think NTRs open up the solar system to everything. So,
yeah, anyway. and I really have no objection to that. I think I look at it more as phases. In a way, you can think of SEP as like the sailing ship phase of space exploration. We need to operate with sailing ships for a while, and we'll use them. At some point, the steamships will come along. We're not quite ready for them yet. I think it would take a lot of money to develop the reactors and get them ready for space.
See, I don't think so. I think we're looking
then maybe that's the debate.
A few $100 million, $500 million in 5 to 7 years, and you got an NTR that can be a ferry for unmanned probes and
So I think
that's the debate.
I think basically where things stand right now, solar electric is being proposed because it's an evolution from things that are flying. I do personally believe that the open discussion and debate needs to be had on what's the right approach, and you know, it's between solar electric, nuclear thermal, and Franklin's Vasmer engine. But I think the discussion needs to be had.
No, I agree.
I definitely think so. Why don't we get to Dan,
Appreciate
and
it.
we'll get back to questions in a minute if you want to.
Okay, we'll take run number 2 at this. First of all, my most sincere apologies. We had a little cross-comm, and I'm sorry, Doug, I owe you one. But let's go. Yeah, you do.
I wasn't going to pass it up.
I'd use it too if I were in your shoes. Okay, let's go to the next, and it hopefully is the video. Uh-oh.
They'll get you there.
Well, while it's hopefully working, what the message that I wanted to leave everyone with, there we go. Okay, so what you see in that video is a lot of the hardware progress that we have made across the Space Launch System, Orion, and Ground Systems team. The Orion work that you saw there with the heat shield and the crew module and the service module all at the ONC building at Kennedy is all about the preparation for Exploration Flight Test 1 coming up this December. So the hardware's moving, the team is putting it all together. We're going through the checkouts as we speak. The Orion crew module is sitting in Florida, going through multi-point vibration test with all of the electrical systems powered up. And things have been working out extremely well. You saw some of the tooling being put in and actually used at the Michoud Assembly Facility for SLS. By the end of May, early June, we'll have the big tower structure in where we will, the vertical assembly center as we call it, where we will put the circumferential welds on each of the cylindrical sections and start stacking tanks. And so the hardware's moving. As we talk about going to Mars and how we're going to get there, the one message I want everybody to clearly understand is how much progress has been made on the hardware for those foundational transportation capabilities that we need to go to Mars however we do it. The Space Launch System is on track. We're working hard for the FY18 launch. Orion's on track for EFT1, and Ground Systems is supporting. We've got everything on contract. We have our contracts basically all definitized. Things are moving. And if we go to the next chart, maybe I'm supposed to have the pointer by now. No, here we go. This gives you, from a still perspective, you see in the upper left-hand corner the service module being put together, the launch abort system across the top. It is inert for EFT1 other than the separation motors. The crew module on the bottom, heat shield being prepared, and if you were to look at that heat shield now, you'd see all the instrumentation cables running through it to get all those measurements that we need for the heat shield performance, and then the forward bay tiles that we have for the top of the crew module. From the SLS, we've talked about the vertical assembly center in the upper left. B2 is well on track for the core stage green run testing that we plan to start in the 2016 timeframe. In fact, the Stennis team's doing a great job on schedule and, believe it or not, under budget. So that's going extremely well. The ATK boosters, we have our qual motor 1 firing later this year in December. We had a few things we had to work out on the aft segment, some voids we discovered as we went through the pouring sequence, but we have fixed all of that, and we're on track for QM1 later this year. And across the bottom, you see the dome tools, the gore panels that we have done all the friction stir weld with. We have done at least one production pathfinder through each of our major tool stations at Michoud. And all of our friction stir welds have come out clean and met all of our requirements. We have not had to redo anything on that front. And in the lower right-hand corner, you see the picture of the shell buckling work that we have been doing in concert with the NASA Chief Engineer's Office that's helping us understand the shell buckling physics better so that we can take out some of the margins that we have to put into our design process and allowing us to still meet all the loads requirements but cut down on a little bit on the weight. In ground systems, the crawler transporters in work. We've been replacing all of the roller bearings, replacing the pads, the flame trench. All the demolition work has been done on pad 39B, and we are in the process of getting ready to, we actually have it on contract now to put the new flame trench in. So the ground systems team's working well. They are practicing and getting ready for the recovery of EFT1 later this December. That's the bottom middle picture that you see there, our underway recovery tests that we're using to get prepped for December. So good progress all along the way in terms of hardware, and the first step is coming up this December on our way to Mars. So we talk about going, we're doing it with the help of people here as well as the team across the country. We are on our way.
Thanks, Dan. Well, it's great to see that significant progress on these components, which are the first critical steps in going to Mars, and great progress being made. And it was good to hear Tabor McCallum this morning. After going through the studies that they did it last year, they came up with a conclusion that these were the right approaches for them too. So that's an independent look at it. They didn't start out on that page, but ended up there. So, but it's good to see this progress. It's very important for what we're trying to accomplish here. Let's get back to questions. Thank you.
This may be far out into the future, but we're talking about the future, and we have about 20 years to watch the development. One of the things that we're really addressing in many of our conversations is propellant, SEP versus nuclear thermal and so forth. My question is relative to perhaps cutting down on the weight requirements to get to Mars. Is there any discussion around the advanced developments, and they seem to be happening rapidly, for 3D printing as it applies to manufacturing? And if so, is it possible to perhaps bring what you need for 3D printing on the advanced cargo missions to the planet to get that building in 3D printing and assembly robotically, so that when humans do get to Mars, they would have these pieces built, versus bringing from Earth already processed building infrastructure, which is weight and space to get there. In other words, bring the materials to Mars and perhaps cut back on the weight, because we're talking about this mass weight, which requires so much to get off the ground.
I think you're absolutely right. I think we're making good progress on that. It's a new technology that's just now developing. We actually, I believe, have a 3D printer on board space station today, which is a big achievement. So we'll get some experience doing that. And I think over the next 10 years, you'll see more evolution and capability. And one of the things that allows you to do is you have to have the raw materials, but you don't make what you need until you need it, and that can save you tremendously on logistics. So it's a great idea.
Yeah.
And along those lines, there's actually, we've manufactured selective laser melting, other forms of the 3D printing. We've actually hot-fired some of those components on the J2X and RS-25 testing that we've been doing as part of the SLS program. So the teams across the agency and across industry are starting to build the hardware, and we're starting to put it into the test programs where it makes sense.
As we go. I mean, we're talking about all these developmental steps. So as the 3D technology progresses, I think we can keep that in mind as optional ways to cut back on mass weight.
Yeah.
That's right.
I think all the technology, basically most of the technologies that are in the list of key technologies, and there are lists like every 5 years over the last 25 years, and they're all very similar, but they're all aimed at reducing mass, because that's such a big driver in the cost. Artemis?
Yeah, I have a remark and a question. The remark is, we all know if we want to go to Mars, we need to get the government behind it. And to get the government behind it, it basically means we need the public to believe in what we are doing is right. Because in the end, the public is footing the bill. Now, it might be that because I live in Europe, but I had no idea that the SLS was coming along as it apparently is. And I think if we want the public to foot the bill, we should have more movies like the one just like this, or documentaries on National Geographic or on Discovery Channel that are viewed by a great number of people in America and in Europe to, to convince them that's a good thing to foot this bill. Because for me, the movie I just saw was on par with Iron Man, Hollywood trailers. So,
late.
So it's, use that. And I think we're not doing that enough, which is a waste, because we're doing the work. Show it.
Well, I think that's a fair comment. We work very hard to try to get that out. That's one of the reasons why we wanted to bring the video over to this audience, is to give everybody a chance to see it. It is out there on the NASA website. You can get a hold of that video. We probably need to help people understand where to go to get it. It would also help if Dan showed up on time with it every now and then. But I think your message is well stated. We are working very hard to try to figure out, given the resource constraints that we have, how we best get out the message. And I think over the next year, you will see more and more of this getting out, not just in the typical aerospace, NASA industry arena, but getting out to a broader context, so that not just the U.S. taxpayers, but people around the world really appreciate how much progress is being made and how much investment's being made. Because I think they want to see it. I know from my own personal experience, traveling around the country, that when people realize that this kind of work is going on, they get excited. They think NASA shut down when shuttle quit flying. And we keep trying to work against that and change that perception. And as they see what's going on, they all get excited and they all want more, particularly the younger generation.
Other questions? Well,
Quick
okay,
question. Two questions. One is if there's an update on the contribution from Europe for the service module propulsion. And the second is what's in the prospective timeline for the upper stage of SLS? What might that look like?
Okay, a couple good questions. First one, the European service module is on track. In fact, we're going through a preliminary design review process right now. We will finish up that preliminary design review next month. And the technical teams are going through all of the data and going through the design now. But that's making good technical progress. We have a couple schedule things we need to work. But other than that, that's well on track, and that partnership is working very well. For upper stage, for the Space Launch System, we are trying to figure out what our options are there. We have trade studies looking at the different possible engine combinations, what that means to the stage design. What we do know from all of our analysis and study is that by going to upper stage as quickly as we can, we get much more, I'll call it deep space performance in terms of payload capabilities up and out. And we're focused on making that happen as quickly as we can. Again, that becomes a discussion about how do you fit it within the budget constraints. But we're going through all that analysis now, and we're trying to get upper stage in as quickly as we can.
Hi, I'm Elizabeth Wallace, and I really did like that film, but it reminded me, my daughter works for DirecTV. She handles the satellite feeds coming into the headquarters in California. But she recently went to a conference with me on suborbital research, and she walked through Bell Aerospace. It was closed at the time, there's nobody working there. She goes, oh my God, I'd love to be able to do this. And she had no idea. She's 34, and now she's like, well, how do I get there? I also am a partner at Parkland Magnet Middle School for Aerospace Technology in Rockville, Maryland. And there are so many kids who come from families whose parents do a lot of manual labor, okay? And they're many Hispanic, et cetera. And I don't think we're showing enough of the technicians' roles to children and how to get there and how to do that. And how do you think that could be brought to the public more?
I think we try to show that. In fact, in some of those videos, some segments of that video, you saw the technicians working on the heat shield, working on the instrumentation cables, doing the inspections. We try to show the hands-on work that's going. I think it probably falls back to Artemis's point earlier, is that we need to get that out to a broader audience so that they have a chance to see it. And point well taken, and we continue to work very hard across the board within the government, within NASA, across the whole NASA industry team. We continue to work hard, and we need to work harder.
Yeah, I think it's a great comment too, and I know within Boeing we can probably do things to bring that out as well. There are many, many different people that it takes to make a space program work, and all of that work is important.
Steve Brody from ISU. Just to pick up on that comment and add to it a bit, obviously there's a lot of great technology in the visualization world where, even though, Dan, you just mentioned there were a lot of technicians there, an uninformed audience, especially students, college level or beyond, may not realize that that person doesn't necessarily have to have a master's or a PhD or whatever. So there may be ways of, doing little windows that says, so-and-so technician would, The other comment, well, the question I was going to have is if there are a lot of university involvement activities that are a part of these developments, that's also a good message I would encourage you to try to bring into this kind of formulation, show university logos or mascots or whatever, but to show that it's grad students, that there's this path forward for our middle schoolers, our high schoolers, and our undergraduates to be engaged and not just, wait till they get to our age to be active in
Right.
this sort of stuff.
Yeah, and that's a very good point, and we try to show the logos of all the ones that are involved. We'll particularly try to focus on Texas A&M and Purdue.
Buzz,
I've got a lot of questions.
I think we're about out of time, though. What's your best one?
This looks almost like a design reference mission. And instead, I think what is needed is a design exploration sequence starting from and carrying everything through. Your use of L2 as a staging point for going to Mars raises some questions as to how do you get people there and back. It looks like you land one habitat and then you land one mission with a crew. How do you check out that habitat from the Earth? That's a long transmission time, and you don't get very much accuracy, which is one of the reasons why you want a Phobos location. You haven't mentioned, but I assume somewhere in here is a lunar lander and a lunar base complex as a building block. If you have an exploration or design exploration sequence, you better include anything you're doing at the moon also, so we know just what to pitch to the people and to the president. Are you taking advantage of the people being informed of anniversaries like 45th and whether there is provision for a second term space objectives of the president? I'm a little concerned that you're not covering what do you do next. Do you have a sequence of follow-ons that seem to continue using the design reference mission over and over again, the way we did in Apollo? I think we need a build-up, and what I mentioned the other day for the Trans-Mars injection, what abort facilities do you have in the event of booster cutoff near attaining the desired velocity?
Thank you, Buzz. I think you did very well in hitting the point I was trying to make starting off, is that it's very important for us to have this plan in this time frame. Early on, right in the next couple of years, next few years, we're getting these developments done. We're getting them tested. In the middle years, if you think about Mars in the 2030s, in the middle years, we need to have that plan, the kind of thing that you're talking about, and groups like this are at least a subset of the groups that need to, of the constituency and stakeholders that need to have an input to that to help lay it out most effectively. So, and to get all the best ideas. So I am a big proponent of laying out that plan. And in fact, I'll quote, just to end, I have another Yogi Berra almost quote. I'd modified it slightly. You got to be careful if you don't have a plan for where you're going, because you might not get there. So I think we need to develop a plan now. It's not too early to understand some of the missions in the next 15, 20 years that we need to start planning for soon. And not that we can put a definite date on it, but we can put it in a time frame and a sequence, as you said, that would make sense. And of course, the budget year to year will dictate exactly when it falls, but you got to have the sequence. And know
Doug,
what
if I
steps to
could
make.
just make a couple of comments too, Buzz, because I think a lot of what you were talking about was addressing some of my charts. And, you know, I think I totally agree with many of the things that you said. And it's important that this dialogue occur, like Doug is talking about, because there are many ideas in this community, and what you really saw was just a collection of ideas from a smaller subset of the community. But there's a lot of value to laying out what the long-term plan is going to be so that you know that all of those pieces are the right pieces along the way, and we have a lot more work to do on that front over the next couple of years.
All right, I want to thank you for your attention. I want to thank Dan and Mike. Appreciate your participation.